Look at that blue sky. This is the first nice day we've had this year. It's glorious. The sun's out and it's warmed up, and I think both my charge controllers are modulating. Yep, that one's modulating. What about this one? Yep, that one's modulating, which is good. Let's head for the shed. Here's the shed. Now I wonder what the temperature is in there with no heating at all. No ant miners. Let's find out. And it is 18 degrees with no heating at all. The ant miners are at rest. They're completely quiet. How about that? Now this video needs to be about something. What can I show you? Don't think I've ever shown this panel, actually. Yes, I'll explain what that does. So let's turn on the middle lighting circuit. That does the strip lights up there, and it also feeds this panel with 12 volts from the lead acid batteries. And this is a little patch bay where I can connect that banana plug, and this light bulb comes on. It's a 12 volt brake light bulb, and this is my new rule. If the banana sockets are 1 inch apart, they're connected. If they're 2 inches apart, they're not. So the 12 volts comes in here. That one's a link, that one's a bulb. And what are we doing? We're charging the supercapacitor. So that's 2 supercapacitors in series. So that's 5.4 volts. And I'm setting the charge rate by this resistor. But I like my resistors to be visible, because as that supercapacitor comes up in voltage, so the voltage across this bulb goes down and it gets dimmer so that you can see what's going on. So yeah, that sets a charge rate by the resistance of that bulb. I don't know what it is. Well, we could work it out. It's 21 watts. I'm not pointing at the bulb, am I? But anyway, it's 21 watts, 12 volts, or thereabouts. And so what does this do, this supercapacitor bank? Well, it provides the 5 volts for this supercomputer. It's just a bunch of flashing LEDs, and you can see now that they've all booted up and they're all flashing. They're quite dim at the moment, despite what it looks like on camera, but they're getting brighter. And as the voltage on the supercaps comes up, so the voltage across that bulb goes down. It's difficult to see, but that's getting dimmer now. So that's my charging the supercapacitors from the 12 volt system. This is the incoming wires. They come from here. They come from that terminal block. They're linked into that terminal block, so they feed off the lighting circuit, and that goes back to here with all these wires, and eventually comes from here. So it's the middle switch that turns that lighting circuit on, which is the lighting circuit I can use to charge those supercaps. What else have I been doing in here recently? Well, I put the supercapacitor powered Bluetooth speaker alongside the vocoder project because they sort of seem related. In fact, why don't I switch it on and just do a bit of vocoder? You won't hear much, but it'll be a bit of fun. So the first thing to do is to take this little lead acid battery off here, and I've got to be careful to put that somewhere safe so it doesn't short out. Let's hang it over there. Is that safe? I think it's fairly safe. So I use this little lead acid battery to charge the supercaps. I'll plug that one. Oop, no, that's not quite in the right place. Plug that one on there, and then I just wedge that one under there. That's supplying a good number of amps. What we got? A little bit over 4 amps. There's some funny effects on here. If I touch the metalwork of this, I get funny effects because this is all relatively high impedance, the opto circuits that reduce the current on this board. Heard a funny click there. Don't like funny clicks when I'm playing with electrical stuff. So I'll let that charge for a bit and get these supercaps up to voltage. Now the first one that comes up, of course, it lights the opto winds the current down on this buck boost, and that will be indicated by the meter needle. I'll come back when that happens. Oh, actually, of course, I've got to switch this thing on, so I've put the other BST 900 here, the one with the LED display. Let's go over to where its plug is. That's this plug. Plug that in to the 12 volt output of that thing. How are those lamps doing? Oh, pretty good. And the bulb's getting dimmer and dimmer and dimmer. Can we see that if I get really close? Not really, it just looks dusty. So those are charging up. That's now on with its 100 volts setting. Oh, come on, that wire's being focused on, isn't it? That's better. Let's switch that on. Shove 100 volts. Oh, I heard something on the speaker then. Shove 100 volts onto my power supplies. They've all lit up, so the vocoder should be active. Let's just see whether it is. If I speak into the microphone. Hello, microphone, microphone, microphone. Oh, and the supercapacitor powered Bluetooth speaker has come up. And you can hear the vocoder. Yeah, that's fun, isn't it? So that's what I do when I come out to the shed. I just play with stuff. I just play. How's this doing? I think it's still running at full power. If I touch, all I have to do is touch it and that meter needle goes up. I don't quite know why. Something very odd going on there. But yeah, if I pump 4 amps into these super caps, one of them will come up and its blue light will come on, and then all the others will come up to meet it. There was some fuzzy noise coming out of this thing, but look, you can see the meter needle is now falling, and that's because that capacitor is up to voltage. The others aren't yet. No, they're not. Haven't got blue lights on the others, but as soon as the first one comes up, the current has to back off because it has to not overwhelm the protection circuit on here, which just simply burns the current up in these 3 resistors at the front end of the circuit board. So now I'm waiting for the little blue light to come on the other caps, and I'll just leave this thing on. Oh, what's that horrible noise coming out of the supercapacitor Bluetooth speaker? The supercapacitor Bluetooth speaker. The supercapacitor Bluetooth speaker, which is connected to the vocoder. Anyway, that's enough fun for today. Goodbye!